I would like to thank our colleagues from the International Conference on the Water Resource and Arid Environment for inviting me to present today the case study about the sustainable desalination industry in the Arab region and to be and participating in this very important event and this important conference. Today we will speak about the importance of the desalination industry in our region and how it could help to fill the gap between the supply and the demand in the water resource. Globally, the desalination sector is growing because the water demand is growing and the freshwater resources are depleting. There is about more than 2 billion people are currently experiencing a water stress and more 4 billion severe water scarcity. So the global water demand is increasing by about 1% every year since the 1980s. And this has put a lot of pressure on the available nature, renewable freshwater resources. Water stress will keep rising and water demand grows and the effects of the climate change depleting or depending. By 2030, the world could face 40% shortfall in water supply. The improvement of water management and desalination are increasingly more places the only available option to meet the rising water demand. Currently, there is about more than 2,000 desalination plants worldwide, producing about 500 million imperial gallon a day. Out of them, about 74% are coming from the reverse osmosis desalination plants, and the remaining are, or which is about 21%, are from the thermal desalination. So the growing are in the reverse osmosis desalination and not in the thermal technology or the old thermal technology. At present, the United Arab Emirates and the United Kingdom of Saudi Arabia or the Kingdom of Saudi Arabia are the most two big countries producing about 40% or 35% out of the total global capacity. Saudi Arabia produce about 2.3 billion cubic meter of desalinated water annually. United Arab Emirates are producing about 2.1 billion cubic meter, and in the third place, United States is coming in the third place and producing about 2 billion cubic meter per year. Globally, most of the desalination plants are from the seawater. The 46% are from the desalinated seawater, and the remaining, which is about the 26%, are coming from the brackish groundwater. There is other sources for reverse osmosis or treated wastewater or desalinated water, but mostly desalinated water from the thermal is decreasing, and the desalinated water from the reverse osmosis are increasing. And we are expecting also a big trend increase in the reverse osmosis in the future due to the use of energy, less use of energy, and the less impacts on the environment. Globally, there is an investment of about $6.6 million of desalination in capex, or $6.6 billion annually in 2021 as a capex cost in the desalination sector, and also $11.1 billion the operational cost in the 2021, which means that there is a huge investment in the desalination sectors globally, either to build a new desalination capacity or to operate the existing desalination capacity. It's expected to be increased to be 32 billion by 2027, which is a big investment in the desalination, increasing the desalination capacity globally. The cost of the desalination coming from different items. The main costs are coming from the power cost or the energy consumption, which is about 26%, and the RO and the construction costs are measuring of about 30% out of the total, and the other items like the intake, the discharge and the construction cost, the treatment of the construction cost, the project engineering and permitting, and other items costing very less cost, which is ranges between 10% to 6% in some items. But still, the two major items in the cost are the energy consumption and the reverse osmosis and construction. This is we are speaking about the reverse osmosis desalination plants. In our region, in the Arab region, the main source of the water still is the surface water, and the renewable freshwater availability in our region declining with time and decreasing with time. In 1960, the per capita water share was about 3,400 cubic meter per capita per year. Nowadays, we are speaking about less than 400 cubic meter per capita per year. So it is declining very dramatically due to the increase of the population and the increasing of the demand. So we have to find another alternative solutions to fill the gap between the existing supply and the increasing and growing demand. Desalination is considered as one strategic option. However, there is some limitation, mainly due to the cost and the energy consumption, and also due to the environmental impacts. But in our region, there is more than 9,000 desalination plants producing about 39 million cubic meter of installed capacity a day, which contributes by about 48% out of the total 95 million cubic meters of desalinated water produced every year worldwide. So we are in the Arab region, we are 48% out of the total global produced desalinated water. So this is also big and huge contribution for our region. We have a lot of big and mega desalination plants in our region, including Ras Al Khair in Saudi Arabia, Al Khobar, Al Tawila in United Arab Emirates, Fujairah, and Rabigh, and Shuaiba. This is producing about, some of them produce about 1 million cubic meter or 1.4 million, like Al Khobar in Saudi Arabia. This is a huge capacity exists in our region. There is a lot of challenges and impact of the desalination sector on the climate. The first challenge is the cost, of course, and as I mentioned before, at present now the consumption of energy for the reverse osmosis ranges between 3 to 5 kilowatt hour per cubic meter, with an average of 3.5 kilowatt hour per cubic meter, which is consumed huge. Of course, in the thermal, this is increased to be between 15 to 20 equivalent kilowatt hour per cubic meter. So, which means that the cost of 1 cubic meter in the thermal at the production on the cost, it ranges between 2 to 3 Riyal Saudi or Emirati dirham, which is about mainly 0.7 or 0.8 dirham dollar. And if we go to the reverse osmosis, well, this will be a little bit smaller. It will be about 0.5 or $0.4 per cubic meter. But still, it is not affordable for some of the inhabitants or the population in the Arab region, which is their economic are not, they cannot subsidize the desalination or the water production. So the cost is still a little bit high and needs some investment from the government or some subsidy from the government. And it needs a high capital investment. 1 cubic meter from the desalination as a capital cost from the capacity of each desalination plant as a capital source will be between $900 to $1,200 with an average of $1,000. So if I need to build desalination plants with a capacity of 100 cubic meter per day, this means I need $100,000 for the capex cost. Operational wise, it ranges between $0.5 to $1.5, depending on the as it is reverse osmosis or thermal desalination. Other issue is the carbon emission. Between 2.1 to 2.6 kilogram of carbon emission will be for each cubic meter of produced desalination plant. Depends also in the method used, either RO or thermal technology. Worldwide, the operational desalination plants emit around 76 million tons of carbon dioxide every year, which is a huge amount of carbon dioxide. The emissions are expected to increase to around 500 million tons of carbon dioxide per year by 2040 if no action has been taken or we are not using alternative water energy sources to supply or to operate the desalination plants. طب how we can overcome these two big challenges, which is the cost, energy consumption, and the environmental impact due also to brine discharge back to the Gulf or to the sea. First of all, we have to use renewable energy like solar desalination or desalinated plants operated by winds or nuclear energy to decarbonize the water production and to minimize the carbon dioxide emissions. There is a lot of trials within our region, in GCC region and the Arab region, to use solar desalination. One of them was a pilot project constructed in 2014 in United Arab Emirates. We called it Ghantout Desalination or Renewable Desalination Pilot Project. 5 desalination units as a pilot were constructed with a capacity between 1,500 to 2,500 cubic meter a day. And they are using solar energy. And there was a demonstration stage between 2013 to 2017. The 5 pilot projects were assessed very carefully, and we find that it is sustainable to use solar desalination, especially with the decline in the solar energy price and the increase in the efficiency of the solar panels. So solar can be a good and a potential solution and alternative for using renewable energy in the future to operate the desalination and to overcome the environmental impacts and the cost. One of the other issues is to harvest the brine water instead of discharging it to the environment or to back to the Gulf or the sea, and produce industrial salts or different minerals which could be used industrially. This is also there are many promising pilot projects. One of them in Saudi Arabia in El Jubail desalination plants. They are now trying to harvest the brine water to produce salts, industrial salts, and minerals. There is also a trial now in Sultanate of Oman, and there is a project now under approval in United Arab Emirates. This is considered also as a very promising and a potential field for more research and development and more investigation commercially in the future to harvest the brine water and using it for minerals production and salts production. One of the important issues is the impact of the chemicals used during the processing and the desalination on the marine ecosystem, and also the brine water discharge with a little bit higher temperature between 5 to 7 degrees above the ambient marine water and its impact on the marine ecosystem. The design of the outlet of the desalination can help us to overcome this environmental impact and to dilute the water with the cold water to minimize the salinity of the brine water and also the temperature, and to minimize its impact on the marine ecosystem. Here I would like to come to a very big commercial solar desalination plants recently have been floated as a tender in the market. It is called the Tawila 2. Tawila 2 is considered as 45% of the largest than any current reverse osmosis, and it is a solar desalination plant. The tender was floated, and I think they are now under the process of the selection, of the final selection and awarding. It will produce about 1 million cubic meter a day, which is 220 million imperial gallon a day is the capacity. And the construction cost or the capex is about $874 million investment in this desalination plants. It will also produce about 45 megawatt in terms of electricity, and it will reduce about 2.4 million tons of carbon dioxide emission every year, which is equivalent to 470,000 cars out of route. The energy consumption, it is a breakthrough achievements in this desalination plants according to the design by the company awarded the project. It's expected to consume between 2.8 to 3.3 kilowatt hour only per cubic meter, which is considered as a breakthrough or big achievements in this plants. Recently, also, there is a study, big study done in many GCC region and Arab region to use even the desalination for irrigation and the producing of food, not only for potable water supply and domestic supply, but also for the production of food. Recently, there is a desalination plants constructed in Saudi Arabia and in the United Arab Emirates, and there is a big study done by IDOM consultant with Wageningen University and the Ministry of Environment, Water and Agriculture in Saudi Arabia to investigate and assess the potential and the economic of using desalinated water for agriculture. In United Arab Emirates, in the Northern Emirates, there is a constructed desalination plants with a capacity of 94.4 million imperial gallon a day. And the capacity of this one is 150 million imperial. However, the production is about 95 million imperial gallon, and it will be used for irrigating about 3,200 farms. And the production cost, it is the reverse osmosis desalination plants, and the production cost is estimated to be 1.54 Emirati dirham, which is less than $0.45. And there is now they are speaking about the tariffs for using desalination plants, and the United Arab Emirates government, they put some tariffs which is between 1.5 fils if you are using less than 20,000 gallon a day, to more than or about 2.5 fils Emirati dirham fils per gallon if you are using more than 50,000 imperial gallon a day. The preliminary results indicating that even the desalination could be in the future using for food and improving the food security within our region. As you are all know, the food security in our region now is less than 15% in some countries, especially in GCC countries. In United Arab Emirates, it's about 13%. And I'm sure in the other GCC countries is very low, and most of the food are imported from outside the countries or our region, which also means that there is a lot of investment on or a big bill or invoice for importing food from our side outside our region, which means that we have to invest more and to find alternative water solution to improve our food security ratio and the self-sufficiency ratio from the food. Desalination could be an option if we use special technologies for irrigation and the advances and innovative technologies in the agriculture production. In general, desalination could be considered as a strategic, and as a conclusion, desalination could be considered as a strategic option for supplying the water for both the potable water supply or agriculture in the future. Innovative technologies can help us to improve the three challenges facing the desalination sector, which is the cost, the energy consumption, and the environmental impact. In terms of cost, new innovative technologies can help us to reduce it a little bit, and also using renewable energy can improve the environmental impacts by harvesting also the brine water. And the energy consumption could be, there is a breakthrough now in some desalination plants in Saudi Arabia to reach 2.2 or 2.3 kilowatt hour per cubic meter, which is also a breakthrough. So we have to have more research and development in the future to improve the desalination sector in our region, to lead and to improve and to increase the local supply, because most of the construction material or the tools and equipments coming from outside our region, I think we have to invest more to produce this locally and to increase the local supply to the desalination industry, and to have more research and focus and to build the capacity in terms of training, especially for the technician, for the operators in the desalination sector, to improve the whole process and to have the know-how and to have the capacity the resources and the human resources capacity to operate and to monitor and assess the use of desalination and improve the desalination process. This will help us to lead and to improve our desalination sector in our region in the future. With this, I would like to thank you again. I would like to thank the head of the session and the chairman of the session and the team inviting me to be with you today. Thank you very much.